Hello, I am Jacob Barton.
I'm Marley Peck.
I'm Josh Kim.
And this is the comparison of the geology of the moon compared to Earth. So the outline of this presentation is going to be, first we're going to start off with the introduction, and then we're going to move on to the history of the Earth to compare it to the history of the moon. And then we're going to go into the composition of the Earth and moon, and then the surfaces of the Earth and moon, and we're going to wrap it up with a conclusion. So to start.
Okay, so obviously we've been learning about the geology of the Earth a lot in class right now, and how the Earth works and about tectonic plates, but we really haven't learned anything about the moon yet. So today we're going to be comparing these two planets in our solar system. So in order to completely understand the geologies of each, it would make sense to first discuss the history of the Earth and moon. So I'll be discussing the history of the Earth today. And the most widely accepted theory for how the Earth was created is called the core accretion model. So, according to the core accretion model, the Earth started off as a nebula, which is a cloud of dust and gas in the solar system. And what happened was gravity made this nebula to collapse in on itself, and it started spinning. So when this started spinning, the first thing that formed was the sun as the center of the solar system, and then these rocky materials that were in the nebula and still spinning around started to clump together. And according to Sanjay Ramesh, the Earth started off as like a mini planet, and materials just kept on like clumping onto it because of gravity. So this is what's referred to as accretion. That's why it's the core accretion model. And these materials sorted themselves by density. So the core formed first with the most dense materials, then the mantle with the middle density materials, and the lightest materials rose to the top, and that formed the crust. And then the Earth continued to grow for 100,000 years after the formation of the Sun. So a little further into the history of the Earth, eventually comets and asteroids hit the Earth, and they were made of water and ice. So this brought along with it a lot of water vapor, which eventually fell onto the Earth as rain. And according to Space.com, these bodies that collided with the Earth most likely brought a lot of the Earth's surface water. And this was essential to life on Earth after that. So the reason the Earth's surface water doesn't freeze or evaporate all over the Earth is because it's in a zone where it's either hot or cold enough for this to happen. And among Earth's water being deposited, also at this time lava was flowing over the Earth for 700 million years, and it was making Earth's surface change a lot. And also oceans were being formed at this time as well. And in the early years of Earth, during the Precambrian era, the sun was able to see, or the Earth was able to see the formation of its moon. And also the Earth had a lack of oxygen at this time because there was a lack of plant life. So there wasn't very much life on Earth because this caused the atmosphere to be really weak and toxic, but there were still some life forms called simple cells. And according to Ramesh, because of the weak and toxic atmosphere and the changes in climate at this time, the Earth experienced 5 mass extinctions. And we can tell that all of these changes have occurred because of a study called stratigraphy and the study of the rock layers, because the rock layers hold the history of our Earth and over the millions of years. And we were able to create a geologic timescale from this, as you can see here on the right.
So now we're going to go into the history of the moon for comparison. There are 3 main hypotheses for how the moon was created. And these are the giant impact hypothesis, the co-formation theory, and the capture theory. I'm going to start by going in the most recognized to least recognized order, and this starts off with the giant impact theory. So Theia was a planet about 60% the size of Earth, about the same size as Mars, and billions of years ago it crashed into Earth, according to the giant impact hypothesis. And this causes a chunk of the Earth to break off, and that is what we now consider the moon. This, of course, is the most accepted hypothesis. The only problem with this hypothesis is that 60% of the moon would be the same material as the Earth, since it directly broke off from the Earth. And the missions to the moon, the Apollo missions, showed that that was not in the case, since the composition was a little bit different than the Earth. The second theory is the co-formation theory, and again, Theia, the theoretical planet, crashed into the Earth, and it kind of fused together, but left a bunch of space debris orbiting around the Earth, and eventually the space debris just collected together to form the moon itself, and that is now what we see in the sky today. And lastly, we have the capture hypothesis. This is the least accepted theory, and it is widely different than the other two theories since there is no theoretical Theia planet that crashes into the Earth. Instead, the moon was just a satellite going throughout space and just kind of picked up by the Earth, and it just started adapting to the orbit, and it became what we have today.
So the surface of the... Yeah, that's yours.
Oh.
I thought you were anything about it.
So the history of the moon was that millions of years ago, this is what we do know, is that millions of years ago giant lava flows were present on the moon, and the newly formed moon was kind of in a molten state. This was probably from the impact of Theia causing high heat to form, melting a lot of rock, and this eventually formed a core from cooling, and then a mantle and a crust. And the moon's volcanoes have been inactive for millions of years, probably since it's just out in space, and it's just constantly being cooled, and it doesn't have quite the atmosphere to keep the heat in. And this weak atmosphere allows for imprints, like footprints, to stay on the moon, since there is no weathering or erosion to go on and cause the effects of change in that nature. So the composition of the Earth and Moon is that the Earth has top 4 elements, and these elements were iron, oxygen, silicon, and magnesium. This is a little bit different from the Moon, since the Moon's top 4 elements were iron, oxygen, silicon, and aluminum.
Okay. So the surface of the moon is about 40,000 square kilometers. It's made up mostly of silicon and oxygen. There are no signs of biological life on the planet, and is actually known as geologically dead because there's not a whole lot of diversity. And it's covered by regolith, which is dry, powdery, small rock fragments. And there's 2 types of surfaces, which is the mare and the terra. Okay, so the mare is vast basaltic plains that form from the lava on the planet. This makes up less of the planet than the highlands. The highlands actually formed from impacts and are very dense. The mountains around these craters are the highlands make up 83% of the moon's surface, and the edges of the craters are the mountains on the moon. And you can see those very well from the picture, where the high spots and the low spots in the basaltic plains are. The surface of the Earth is about 510 million square kilometers, which is much larger than the moon, but its composition is fairly similar to that of the moon's. Sedimentary rocks are the most common, which is different from what the moon has on its surface, and we have a very strong atmosphere that can support life. But our planet is also constantly changing because of plate tectonics. So, in conclusion, the composition of the Earth and the Moon is similar, which supports the theory that we had an impact that separated some material off of the Earth. The top 4 elements that compose both celestial bodies are pretty much the same, and the most widely accepted theory is that another planet crashed into our planet, which created material that then started revolving around the Earth. There's the sources.
Does anyone have any questions for them? What would you say the biggest difference is between the Earth and the Moon?
I would would say that it's like the moon doesn't really have like any like the moon has been like geologically dead, and the Earth is constantly changing. So I think that's the biggest difference.
Anyone else? Thank you.